In exercise 1.4, in the first problem is given, we have to determine whether the graph given below represents a function, and we need to give a reason why it is a function. Now we should decide to use whether horizontal line test or a vertical line test. What is a horizontal line test? It is the given curve is a function, and if the horizontal line touches the curve at most one point, then we call it as a one-to-one function. So in a horizontal line test, it is used to find whether the given function is one-to-one or not. Whereas in a vertical line test, it is used to find whether the given curve is a function or a not. So what should we use now? We should use a vertical line test to check whether the given curve is a function or not, because we are asked to find the given graph represents a function or not. Let us draw a vertical line in all the graphs given and we will find. So if I draw a vertical line over here, it touches the curve in 2 points, P and Q. Therefore, this curve doesn't represent a function. The vertical line touches the curve at 2 points P and Q. Therefore, it is not a function. Okay. For the second problem, we will draw a vertical line this side. It represents a function or not? Yes, it represents a function because the vertical line touches the curve at most 1 point. So, the vertical line touches the curve at a point P. Therefore, it is a function. And in the third option, we will draw the vertical line towards the right. If I do so, it touches more than 1 point. It touches at 3 points, P, Q, R. The vertical line touches the curve at 3 points P, Q, R. Therefore, it is not a function. The curve doesn't represent a function. We will move on to the fourth option. We will draw a vertical line this side. The vertical line touches the curve at only 1 point P. Therefore, the vertical line touches the curve at point P. It represents a function. Second problem is f is a mapping from A to B is a function defined by f of x is equals to x by 2 minus 1, where A is given with a set of values, B we have to represent f by set of ordered pairs, table, arrow diagram and a graph. We will do one by one. We are given with a set of values A and B, but we don't know for what value of A it is mapped to what value of B. For that we can use this function. We will find out, then we will represent f as such. So what we have to do first is f of x is equals to x by 2 minus 1. We will consider this as equation 1. We will take the values of x as values from A. So first if I consider x as 2, so I have to substitute the value of x as 2 in the first equation. So 2 by 2 minus 1, 2 by 2 1, 1 minus 1 it is 0. So 2 is mapped to 0, 2 is mapped to 0. Next we have to substitute the value of x as 4 in equation 1. Therefore 4 by 2 minus 1, 4 by 2, 2 minus 1, 1. Therefore 4 is mapped to 1. Next value of x is 6. So 6 by 2 minus 1, 3 minus 1, 2. 6 is mapped to 2. Next we have to take the value of x as 10. So substituting here 10 by 2 minus 1, 10 by 2, 5 minus 1, 4. 10 is mapped to 4. Next f of 12 in the sense we have to substitute 12 in x in first equation. 12 by 2 minus 1, 12 by 2 is 6 minus 1 which is 5. Therefore 12 is mapped to 5. So we have completed with for the all values of x. Now we will represent in 4 ways. First way of representation is set of ordered pairs. So we represent the function f as we got 2 is mapped to 0, therefore 2 comma 0. Next 4 is mapped to 1, 4 comma 1, and the third option is 6 is mapped to 2, 6 comma 2. Fourth option is 10 is mapped to 4, therefore 10 comma 4. And the next one is 12 is mapped to 5, therefore we have to represent it as 12 comma 5. So the first option is over. Second option is we have to represent it in a table. X and y, x has a set of values 2, 4, 6, 10 and 12. Whereas 2 is mapped to 0, 4 is mapped to 1, 6 is mapped to 2, 10 is mapped to 4 and 12 is mapped to 5, and they are the values in y. We have done so. And in the third option we have to represent it using an arrow diagram. X values, that is a and b. A is given as 2, 4, 6, 10, 12. B is given as 0, 1, 2, 4, 5, 9. According to the function, 2 is mapped to 0, 4 is mapped to 1, 6 is mapped to 2, 10 is mapped to 4, 12 is mapped to 5. Last we have to represent it using a graph. Along x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Along y-axis 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, according to the function we got 2 comma 0, 2 in x and 0 in y. Therefore, we have to 2 in x and 0 in y. 2 comma 0. Next point is 4 comma 1, 4 in x and y in 1 in y. So 4 comma 1. Next is 6 comma 2, 6 at x and 2 at y. 6 comma 2. Next is 10 comma 4, 10 at x, 4 at y. 10 comma 4. Next point is 10 comma 4, 10 at x and 4 at y. So it is 10 comma 4. Last point is 12 comma 5, 12 at x and 5 at y. 12 comma 5. So we have to join the points we plotted. So this is how we represent a given function in a graph. So in the third problem we have to represent the given function through 3 types, that is in an arrow diagram, table form and a graph. Let us represent it. So first an arrow diagram. A, B, whereas values in the first place represents the values in A and the values in the second place represents the values in B. So first is 1, 2, 3, 4, 5 and the second set has values 2, 3, 4. 2 is a repetition. So it is enough to represent only one time. So 1 is mapped to 2, 2 is mapped to 2, 3 is mapped to 2, 4 is mapped to 3, 5 is mapped to 4 according to the given function. Thus we have represented in an arrow diagram, and the second one we have to represent it in a table. X, Y, 1, 2, 3, 4, 5. 1 is mapped to 2, 2 is mapped to 2, 3 is mapped to 2, 4 is mapped to 3, 5 is mapped to 4. And the third option we have to represent it in a graph. X-axis, Y-axis, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So first point is 1, 2. At X, 1, at Y, 2. So 1, 2. Second point is 2, 2. At X and Y both are 2. So 2, 2. 3, 2. At X, 3. At Y, 2. So 3, 2. Next 4, 3. At X, 4. At Y, it is 3. So 4, 3. Next 5, 4. At X, 5. Y, 4. 5, 4. So we have to join the points we plotted. So the fourth problem, we have to show that the function f is a mapping from a natural number to another natural number, which means natural number starts with 1 and it is defined by f of x is equals to 2x minus 1. We have to show that this function is 1 to 1 but not on to. Okay, so using this function f of x only we can show that. So first what will we do is we will consider the given function f of x is equals to 2x minus 1. We will consider this as equation 1. Now what we have to do is f is a mapping from a natural number to another natural number. So let us vary the values of x from 1. So if I take the value of x as 1, I will get 2 into 1 minus 1, 2 minus 1, which will give me 1. Next I will take the value of x as 2, 2 into 2 minus 1, 2 2s are 4 minus 1, 3. So if it is 1, it is mapped to 1. For 2, it is mapped to 3. Next f of 3, that is I am taking the value of x as 3 and substituting here 2 into 3 minus 1, 6 minus 1, which is 5. So for 3 I got 5. From this itself we can come to the conclusion, but it does not end here, it goes on. We have to vary the values of x. Okay, so let us use the arrow diagram to show it is 1 to 1 but not on to. We will consider two sets A and B, whereas it is a function from natural number to another natural number. So we have to start from 1, 2, 3, 4, 5, 6, 7, 8, it goes on. Similarly B also the same to another natural number, therefore 1, 2, 3, 4, 5, 6, 7, 8, it goes on. If we took 1, it is mapped to 1. Next we took 2, it is mapped to 3. Next we took 3, it is mapped to 5. So from this itself we can come to a conclusion that every distinct elements have a distinct images. If I take 4, I will have some other image. So it is 1 to 1 function, whereas many elements in this doesn't have a pre-image. Therefore it is not an onto function. It is an into function. We are asked to show that it is 1 to 1 but not on to, hence we have proven. The sixth problem is we have to show that the function f is a mapping from a natural number to another natural number and it is defined by f of m is equals to m cube plus m plus 3 and we have to show that it is a 1 to 1 function. We follow the method same as we did to the previous problem. So first we will consider the given function f of m is equals to m cube plus m plus 3, this as equation 1. Now what it is said is it is from a natural number to another natural number. So we have to vary the values of m from 1. So I will take the value of m as 1 first. It will become 1 cube plus 1 plus 3, 1 plus 1 plus 3, 3 plus 1, 4 plus 1, 5. Therefore, 1 is mapped to 5. Next, if I take the value of m as 2, 2 cube plus 2 plus 3. What will I get? 2 cube is 8 plus 2 plus 3. It will give me 10, 13. So, from this itself, we can conclude whether it is a 1 to 1 function or not. Let us check using the arrow diagram. I will consider an arrow diagram. Set A, B, both are from a natural number to another natural number as it is given. 1, 2, 3, 4, 5, 6, 7, 8, it goes on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it goes on. So according to the given function, 1 is mapped to 5. Next 2 is mapped to 13, 12, 13. If I take 3, I will get the next number after 13. So from this itself we can come to the conclusion that every distinct elements have a distinct images. Therefore this is a one-to-one function. So in sixth problem we are given with the set A as 1, 2, 3, 4 and B is a natural number. Natural number means starts with 1 but it's some natural number, it is not defined, but f is a mapping from A to B, it is defined by f of x is equals to x cube. Then we have to find the range of f and identify the type of function. Range of f can be easily found because we are given with the values of x as well as we are given with the function f of x. If we substitute the values of x in this, we will find the range of f. Also we will identify which type of function it is. So first what will we do is, we are given with f of x is equals to x cube. Now first we have to find the range of f. So range of f means we are given with the function f of x is equals to x cube. This we will consider it as 1. We will vary the values of x as given. So first is value of x is 1. If I substitute 1 cube is 1. Next f of 2. If I substitute here, it will become 2 cube 8. Next f of 3. F of 3 in the sense substituting here 3 cube is 27. Next f of 4. Value of x as 4. 4 cube 64. 4 4 are 16. 16 into 4 64. So this is our range. 1, 8, 27, 64. So second point is we have to identify the type of a function. A set is given as 1, 2, 3, 4 and the B set is given as natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it goes on. According to the given function, 1 is mapped to 1. Next 2 is mapped to 8. 3 is mapped to 27, 4 is mapped to 64. So from this itself we can identify every distinct elements have a different distinct images. Therefore it is one-to-one and there are many elements which doesn't have a pre-image. Then it is said to be an into function. Therefore this is a one-to-one and an into function.